Hello students, in this video we are going to discuss about refraction through a rectangular glass slab. As we have studied that whenever light ray passes from one medium to other, that ray bends, it changes its path, it bends either towards the normal or away from the normal depending upon whether it is moving from a rarer medium to a denser medium or vice versa of it. So this phenomena of bending is called refraction, and now we are going to see how it happens when we have a glass slab, because if we have a glass slab then we have two media, one is air and the other is glass, and light ray is either passing from air to glass or it is going from glass to air. These are two interface from where light is passing from air to glass at this point, and at this point it is moving from glass to air again. So here we are going to study about the refraction when we have a rectangular glass slab. So for this we consider a glass slab. Let us name it as PQRS. So this is a glass slab that we consider. Now a ray AB, we have incident a ray AB on the face PQ, then the angle that this ray make with the normal is called angle of incidence, that is I. So this angle is I, and this ray get refracted and moves from the path BC. This ray move along the path BC, and the angle that is made by the refracted ray with the normal is called angle of refraction. Okay, so light ray comes from A, it get refracted at B and moves along BC, but at point C it again passes to air and undergoes refraction. So here we again get angle of incidence and angle of refraction for this point. That's why we are going to name it as I1 and R1, and those angles which we get here we'll put them as I2 and R2. So the angle that the ray BC make with the normal is the angle of incidence for this refraction that is happening here at point C. Means when light is moving from glass to air, then its angle of incidence is I2 and angle of refraction is R2. So when light ray pass from air to glass, its angle of incidence is I1, angle of refraction is R1. But after that, when it goes from glass to air from point C, then its angle of incidence is I2 and angle of refraction is R2. So this is how we can draw the diagram. But this ray, this is the final ray that is coming out of the glass slab, we call this ray as emergent ray. The ray that we get out from the glass slab is called emergent ray, and the ray that we have incident is called incident ray. जो हमने इंसिडेंट किया था that is the ray of incidence or incident ray, and the ray जो हमें आउटपुट में मिला है इधर बाहर out of the glass slab, that is the emergent ray. Now if we observe emergent ray and the incident ray, then we observe that this emergent ray is actually parallel to the incident ray, but it is shifted laterally. So this is lateral, right? Shift हो गया है ये in the parallel way. So emergent ray is parallel to the incident ray, but it is laterally shifted, and this distance between the two parallel directions, this distance is called lateral displacement or lateral shift. So this distance is called lateral displacement or lateral shift. Now अभी हमने ऑब्जर्व करने से बोला दैट दीज टू रेज आर पैरेलल, बट इसे हमें प्रूफ भी करना पड़ेगा दैट दीज टू रेज आर पैरेलल, एंड टू प्रूव दैट वी विल प्रूव कि ये जो एंगल ऑफ इंसिडेंस है I1, this angle of incidence I1 is equal to the angle of refraction R2. If I1 is equal to R2, नॉर्मल के साथ बनने वाले एंगल अगर सेम हो जाएंगे, इन दैट केस दीज टू लाइन्स विल बी पैरेलल. सो वी कैन प्रूव these two directions, these two lines parallel mathematically by proving I1 equals R2. And to prove this, we are going to use Snell's law. So from Snell's law, we know that sine of angle of incidence upon sine of angle of refraction is equal to constant and is equal to the refractive index of medium 2 with respect to medium 1. So in this case, first I am talking about air glass system. So in this case, angle of incidence is I1, angle of refraction is R1, and refractive index that we will get will be of glass with respect to air. Second medium is glass, first medium is air. So we can write Snell's law for this air glass system as sine I1 upon sine R1 is equal to A mu G. Now this is the refractive index of glass with respect to air. Let it be equation number 1. Now for the second case, means for refraction at this phase, for refraction at phase SR, or for glass air system, means glass to air, light rays moving from glass to air, or we can write it as for phase SR or RS. So in this case, if we apply Snell's law, we get sine of I2, I2 is the angle of incidence, upon sine of R2, right, upon sine R2 is equal to G mu A. The value we get here is G mu A, because second medium is air and first medium is glass. So we are getting refractive index of air with respect to glass. This is equation number 2. Now let us multiply equation number 1 and 2. We get sine I1 upon sine R1 into sine I2 upon sine R2 is equal to A mu G into G mu A. But from the principle of reversibility, what we know is A mu G is the reciprocal of G mu A. So G mu A को हम लिख सकते हैं 1 upon A mu G by the principle of reversibility of light. So this will cancel out and the right side we get is 1. So the right side will be 1 and left side is sine I1 upon sine R1 into sine I2 upon sine R2. Now from the diagram, now we have to see that this is a glass slab. So in this rectangular glass slab, the line PQ or the face PQ is parallel to RS. In this rectangular glass slab, we know that PQ is parallel to RS. If this PQ and RS are parallel and this line BC is a transversal, right? BC is a transversal, that is cutting these two or crossing these two PQ and RS parallel lines. So the angle R2 and angle R1 and angle I2 represent alternate angles for these parallel lines. So since PQ is parallel to RS, angle R1 is equal to angle I2. Since R1 is equal to I2, so sine R1 will be equals to sine I2. And if this value is equal, that means these two will cancel out. Sine R1 is equal to sine I2 hoga, then these terms will cancel each other and we get sine I1 upon sine R2 is equal to 1, which implies sine I1 is equal to sine R2, or if this is true, then I1 should be equal to R2. And if I1 is equal to R2, if these two angles are equal, the angle that the rays make with the normal are equal, then these two rays are parallel, means it shows that incident ray and emergent ray are parallel to each other, but they are laterally displaced. So I1 is equal to R2 shows that AB is actually parallel to CD, but the ray CD has been laterally displaced with respect to incident ray. That means the ray CD is laterally displaced with respect to the incident ray. So we can define lateral shift as the perpendicular distance between the incident ray and emergent ray when light is incident obliquely or making some angle on the refracting slab with parallel faces. Now this condition is only true if these two faces PQ and RS are parallel to each other. So we are considering the case कि PQ RS के parallel है, because अगर ये parallel नहीं होगा then this condition will not be true, these terms will not be cancelled out and we can't get the condition I1 is equal to R2. So lateral shift is the condition that we are defining for a refracting glass slab with parallel faces, and we can define this lateral shift as, I am writing its definition here. So lateral shift can be defined as the perpendicular distance, it can be defined as the perpendicular distance between incident and emergent ray when condition क्या क्या है, when light is incident obliquely, because अगर लाइट नॉर्मल के अलॉन्ग हम इंसिडेंट करेंगे देन वी कांट गेट सच इमर्जेंट रे, इट विल पास इन द सेम डायरेक्शन और इन द सेम पाथ अगर नॉर्मली लाइट को इंसिडेंट किया गया है तो. सो इट शुड बी इंसिडेंट ऑब्लिकली and obliquely on a refracting slab, and that slab should have parallel faces with parallel faces, because only in that condition we can prove I1 is equal to R2, right? So lateral shift is the perpendicular distance between incident ray and emergent rays when light is incident obliquely on a refracting glass slab with parallel faces. So now we know that there is some lateral displacement, but what is its expression, how we can find that? So we are going to find an expression for this lateral displacement. So to find the expression for lateral displacement, I again consider a glass slab, let it be PQRS, and the medium here is air and this is a glass slab, so the medium is glass, and light ray passes from A to B and then to B to C and then from C to D. So the path of ray is shown by A, B, C, D. AB is the incident ray, it gets refracted at point B when it passes from air to glass, then it moves along the path BC and again at point C when it cross this interface SR, it get refracted and start travel in the direction CD. The path is CD and this is emergent ray. AB is the incident ray and CD is the emergent ray, and the distance between this perpendicular distance between the emergent ray and the incident ray, this distance is called lateral shift or lateral displacement that we are trying to find. So for this we are drawing a perpendicular like this, we are drawing a perpendicular on the incident line from point C to get this displacement. This is a perpendicular, I am naming it as CE and its length I am considering as x. So this is the lateral displacement that I am trying to calculate from this diagram. Now this angle that AB makes with the normal is the angle of incidence. The refracted ray makes the angle of refraction R. So the remaining, this angle, if we see this, these two are the vertically opposite angles, so this complete should be I, but this is R, we consider it as the angle of refraction, so the remaining angle is I minus R. Okay, so in triangle CBE, angle CBE is represented by I minus R, angle CEB, this angle is 90 degree. So this is a right angle triangle that we have. So in this triangle CBE, in triangle CBE, sine I minus R I am trying to calculate. Then in this triangle sine I minus R is, sine is perpendicular upon hypotenuse. So for this angle, perpendicular is x and hypotenuse is BC, the length BC. Sine I minus R is x upon BC, or from this we can get x is equal to the length BC into sine I minus R. So now I have to calculate these two terms to find x. Okay, again I am doing again in the triangle BFC. Now this time this triangle, I am taking this right angle triangle. In triangle BFC, if the thickness of this prism is T, so I am considering this as the thickness of the glass slab. So if T is equal to thickness of glass slab, okay, so then this length BF is T, and I am trying to calculate angle. For this angle R, I am trying to calculate cos R. Then cos R is equal to होता है base upon hypotenuse. So for this angle R, base is BF and hypotenuse is BC. So value for cos R is BF upon BC, and it is equal to T upon BC. So on rearranging we get BC is equal to T upon cos R. Now our task was to find x, and for that we need the value of BC. So this value of BC we are going to substitute in the equation of x. Then we get x is equal to T upon cos R into sine I minus R. Now we are applying trigonometric relations for this sine I minus R. So this is sine A minus B, which is equal to sine A cos B minus cos A sine B. So x is equal to T upon cos R, and for sine I minus R we have to write sine I cos R minus cos I sine R. On solving this we get x is equal to T into sine I minus, this will be cos I sine R upon cos R. Now I want to eliminate angle of refraction R from this formula, because when we are doing practical we know the angle of incidence easily, because we are incidenting that ray on the face, so we know the angle of incidence. So my target is to eliminate R, and for that I am going to use Snell's law. So from Snell's law we have refractive index is equal to sin I upon sin R, right? For it we have mu is equal to sin I upon sin R, and according to this sin R will be then sin I upon mu. So we have sin R now, and using this we can find cos R by applying the relation cos R is equal to under root 1 minus sin square R. So we are going to use this to find cos R, and its value in terms of angle of incidence will be under root 1 minus sin square I upon mu square. This is the value of cos R. So now in this formula of x we can eliminate this term having angle of refraction by substituting the value of sin R and cos R. We are going to do this. So this, from this value of x becomes x is equal to T sin I minus cos I. Now sin R का value है sin I upon mu, and the value for cos R is under root. So I'll apply the power half for that, 1 minus sin square I upon mu square power half. This is the required term. Now we can also solve it by taking LCM here. So we get x is equal to t, sin I will be common, and within the bracket it is 1 minus cos I upon mu square का LCM लेंगे, it will be mu square in denominator, and when we take it common, mu square into half will be mu. So we get mu upon mu square minus sin square I power half, right? And this will cancel out. So the answer that was required will be x is equal to t sin I into 1 minus cos I upon mu square minus sin square I half, or under root mu square minus sin square I. This is the required value of x, or the lateral shift. Hence, this is the required answer of lateral shift or lateral displacement, means the distance between these two lines, perpendicular distance between incident and the emergent ray. And there is one special case for this also, means we can find the maximum lateral displacement, or we can find x max. For this, the condition should be, for maximum value of x, this term that we are subtracting from 1, this term should be such that its numerator has minimum value and denominator has maximum value, or we can get the value of maximum lateral displacement when cos I tends to 0 and sin I tends to 1, or we can say that when I tends to 90 degree. In this situation, the value for x max will be t into sin 90, that is 1. So the answer will be t, means this is t, this will be sin 91, or this bracket will also become 1 minus 0, that is 1. So x max के लिए value होगा t, that means the value for this displacement of emergent ray cannot exceed the thickness of glass slab, means the lateral displacement or the lateral shift or the displacement of emergent ray, it never exceed from the thickness of glass slab. It is the maximum value for lateral shift. So this was the required expression for lateral shift when light is refracting from a glass slab, and lateral shift is the perpendicular distance between the incident ray and emergent ray when light is incident obliquely on a refracting slab with parallel faces. This is must, that glass slab should have parallel faces, only then this condition will be applicable. Okay, so this was the expression for lateral displacement.